Hello all and welcome to the thebasics.academy channel. In this video, we are going to solve the problem Dota2 Senate. What the problem statement is. The Dota2 Senate consists of senators coming from two parties. The Senate wants to decide on a change in the Dota2 game. The voting for this change is a round-based procedure. Note down, it is a round-based procedure. In each round, each senator can exercise one of the two rights. Those are ban one senator's right. A senator can make another senator lose all his rights in this and all the following rounds. If a senator bans another senator, the other senator cannot vote in any of the upcoming rounds. The second thing a senator can do is announce the victory. If this senator founds, the senators who still have rights to vote are all from the same party. He can announce the victory and decide on the change in the game. Let us go through the first example to understand what exactly we have to do. We are given a Senate string consisting of R and D, where R is a senator from Radiant party and D is a senator from Dire party. In the first example, the senator from R bans the senator from Dire party. What happens due to this? The senator from Dire party cannot vote in any of the rounds. And in the second round, the senator from Radiant party announces victory. In the second example, we are given a Senate string consisting of R, D and D. What happens? In the first round, the senator from Radiant party bans the second senator. In the first round itself, the senator from Dire party then bans the senator from Radiant party. So this senator remains. At last, what happens? The senator from Dire party announces victory. The constraints to take into consideration are n is equal to Senate.length, n is greater than equal to 1 and less than equal to 10 raised to 4. Senate of I is either R or D. You will think of how can we come to a solution. If we go with the brute force approach, in that case, the time complexity comes out to be big O of n square. We don't want this. How can we accomplish the solution in big O of n time? This is simple. All you have to do is you have to maintain two queues. First queue will hold senators from Radiant party and the second queue will hold senators from Dire party. As you know, at each step you will remove or dequeue. At each step you will dequeue senators from both queues. After dequeuing senators from both queues, you will compare which senator has the minimum index. So, if senator R has index 0 and senator D has index 1, in this case, the senator from Radiant party can ban the senator from Dire party. After banning the senator from Dire party, this senator can now vote in the second round. How can we do that? We do that by pushing this senator to the end of the queue, to the end of the first queue. And what do we push at the end of the first queue? We push the current index on the senator plus n. So this ensures that this senator can vote only after the first round of voting has completed. Same is the case if the senator from Dyer party has index 1 and the senator from Radiant party has index 2. In this case, the Dyer party senator will ban this senator and then it will go at the end of the queue with index 0 plus n. This is all we have to do. First, we have to create two queues, and in these queues, we will push the indices of either R or D. After pushing the indices of the senators belonging to either party, Radiant or Dyer, once that is done, then we are going to dequeue from both the queues as long as either one of the queue becomes empty. When either one of the queue becomes empty, then at last we declare the non-empty queues senators or the non-empty queue as the winner. How can we do that? Let us look at the code. So initially we create two queues. First is Dyer, second is Radiant. N is our Senate.length. In the first step, we create two queues, one for each party senator. We start a for loop starting from I equal to 0 less than Senate.length. If Senate of I is R, we push I or index I into Radiant queue, else we push index I into Dyer queue. In step 2, we dequeue from both the queues as long as one of them is not exhausted. This is the condition. While Radiant.length and Dyer.length, we perform the dequeue operation. This is Dyer senator, this is Radiant senator. Using Dyer.shift, shift is a method available on arrays. What it does, it removes the first element from the array and shifts all the other elements to the left of the array. Then we check whichever index is lesser will ban the greater index. Ban implies the winner will go to the back of the queue with a new index of D senator plus n or R senator plus n, depending on the winner. Here we perform that check. If D senator, that is senator from Dyer party, is less than senator from Radiant party, in that case, we push D senator, that is the current index plus n, to the end of the Dyer queue, else we push R senator plus n to the end of the Radiant queue. By doing this, at last either one of the queue will be empty. When either one of the queue becomes empty, we come out of the loop and then we check if Radiant.length, that is if Radiant queue is non-empty, it implies Radiant party has won. If Radiant queue is empty, it implies Dyer party has won. So what we have done here is, we have solved this problem in big O of n time complexity, and the space complexity for this problem is again big O of n. Since we are storing the senators indices into two queues, Dyer and Radiant. Let us run this problem. It is working as expected. If I submit this, here it says all test cases, 83 of 83 test cases passed. The takeaway from this problem is we have used here the approach of queues and 2 pointers. First, we create 2 independent queues. Then, in those queues, we push the indices of the senator. At last, as long as either one of the queue is not empty, the voting goes on. Whichever senator's index is less than the other senator, that senator bans the senator with the higher index. At last, whichever queue remains non-empty, that party wins. So thank you all for joining today. I hope you would have learned something valuable. If yes, please do like, share and subscribe. Thank you.